Imagine walking across a rough, reddish stone without realizing that beneath your feet lies the material that would one day build skyscrapers, bridges, railroads, and the backbone of modern civilization. For thousands of years, ancient humans passed by iron every single day, never knowing the incredible power hidden inside it. It was everywhere, yet completely out of reach. Without chemistry, without advanced furnaces, and without any understanding of metals, how did our ancestors unlock one of history's greatest technological revolutions? The answer didn't begin beneath the earth. It began in the heavens, with a mysterious gift that literally fell from the sky. Long before humanity learned to extract iron from the earth, it first discovered iron that had fallen from space. Massive iron-nickel meteorites, fragments of the cores of ancient worlds, crashed onto our planet carrying something almost magical, naturally occurring metallic iron. To early civilizations, this was unlike any stone they had ever seen. The ancient Egyptians even called it the metal from heaven. Archaeologists uncovered 5,000-year-old iron beads in the cemetery of Giza, Egypt. They weren't carved like ordinary stone. Instead, they had been carefully hammered, shaped, and rolled, proving that craftsmen already understood this extraordinary material. Centuries later, another remarkable artifact appeared inside the tomb of Pharaoh Tutankhamun. A beautifully crafted dagger whose blade contained unusually high levels of nickel and cobalt, unmistakable fingerprints of meteoritic iron. During the Bronze Age, this celestial metal was rarer than gold and reserved exclusively for kings and nobles. To ordinary people, iron was not a resource. It was a sacred gift from the gods. But this precious metal from the sky raised an even greater mystery. If nature could create iron, why couldn't humans make it themselves? If iron was so abundant, why did it take humanity more than 2,000 years to move from the Bronze Age into the Iron Age? The answer was hidden in fire. Ancient copper furnaces could reach temperatures of around 1,150 degrees Celsius, hot enough to melt copper and bronze with ease. But iron demanded something far more extreme. Pure iron doesn't melt until an astonishing 1,538 degrees Celsius. To Bronze Age metalworkers, iron ore appeared stubborn and lifeless. No matter how fiercely the flames burned, the reddish rocks refused to become liquid metal. Then, history changed through what may have been a remarkable accident. At ancient copper workshops, such as Quemo Bolnisi in present-day Georgia, craftsmen sometimes added hematite, an iron ore, as a flux to help remove impurities from molten copper. Inside the oxygen-poor furnace, carbon monoxide produced by burning charcoal stripped oxygen away from the iron ore. Instead of melting, tiny particles of metallic iron quietly formed at the bottom of the furnace, fused together into a porous, sponge-like mass. Without realizing it, those copper workers had stumbled upon one of the greatest discoveries in technological history. Humanity had found a way to create iron without ever melting it. Now, imagine you're standing beside one of these primitive furnaces over 3,000 years ago. Smoke fills the air. Charcoal crackles beneath your feet. Every breath carries the smell of ash and burning earth. Would you have recognized that history was about to change? The breakthrough came with a remarkably simple invention: the bloomery furnace. Built from clay and powered by charcoal, it never became hot enough to melt iron. Instead, craftsmen layered iron ore and charcoal inside the furnace, while leather bellows pumped a constant stream of air into the fire. Slowly, something extraordinary happened. The oxygen was stripped away from the ore, leaving behind a glowing, sponge-like mass of metallic iron mixed with molten slag. It looked nothing like the shiny metal we know today. In fact, most people would probably have thrown it away. But not the blacksmith. He pulled the red-hot bloom from the furnace and began hammering it relentlessly. Blow after blow, sparks exploded into the darkness. Each strike squeezed out impurities, welded tiny iron particles together, and transformed a brittle lump into tough wrought iron. Here's the incredible part. The blacksmith wasn't just shaping metal. With every strike of the hammer, he was unknowingly forging the future of civilization. At this point, you might be wondering, If wrought iron was finally possible, why didn't it immediately replace bronze? Because iron still had one fatal weakness. It was tough, but it was also relatively soft. A wrought iron sword could bend in battle, while a well-made bronze weapon often held its edge longer. It seemed as though humanity had reached another dead end. But then, blacksmiths noticed something strange. When a piece of iron remained buried inside glowing charcoal for hours, it came out. Different. Harder. Sharper. Stronger. They had no idea why. Today, science gives us the answer. Tiny carbon atoms from the charcoal slowly diffused into the hot iron. Less than 1% carbon was enough to transform ordinary iron into steel, a material that would reshape human history. Then came the final discovery. When the glowing steel was plunged into cold water, clouds of steam erupted into the air. The blade became dramatically harder, capable of cutting through bronze weapons that had once dominated the battlefield. Think about that for a moment. The blacksmith believed he was simply mastering fire. In reality, he was unlocking the atomic secret of steel nearly 3,000 years before anyone understood what an atom even was. And once steel appeared, the Bronze Age was living on borrowed time. By around 1200 BC, the ancient world was collapsing. Powerful kingdoms fell. Great cities burned. Trade routes that had connected civilizations for centuries suddenly disappeared. And with them vanished one crucial ingredient of bronze: tin. No tin meant no bronze. For generations, bronze had been the metal of kings. It depended on rare materials transported across thousands of miles, making weapons and tools expensive enough that only rulers, nobles, and elite warriors could afford them. Iron changed that forever. Unlike tin, iron ore was almost everywhere. Beneath hills, inside mountains, and scattered across countless landscapes, it waited to be discovered by anyone willing to master the furnace. Think about this for a second. What happens when the most powerful technology in the world is no longer controlled by a handful of kings? Everything changes. Farmers forged stronger plows that could cut through hard soils once impossible to cultivate, producing more food than ever before. Ordinary soldiers carried iron swords instead of costly bronze weapons. Massive infantry armies began replacing elite chariot forces that had dominated battlefields for centuries. Iron didn't simply create better tools. It redistributed power. For the first time in history, technological superiority was no longer reserved for the wealthy. The metal, once considered a gift from the heavens, had become the foundation of everyday life, quietly reshaping economies, warfare, and civilization itself. From a simple clay furnace to modern steel mills, humanity transformed iron into the foundation of civilization. The bridges we cross, the railways we travel, and the skyscrapers that define our cities all exist because our ancestors unlocked the secret hidden inside an ordinary rock. Iron wasn't just another metal. It became the skeleton of the modern world. If you enjoyed this journey, don't miss our next documentary. Before iron changed history, another metal had already captured the imagination of ancient civilizations. How did ancient humans first discover gold? Join us next time as we uncover the remarkable story of the world's first precious metal, and how its dazzling beauty helped shape kings, religions, and the earliest civilizations.